guys, and today we're going to be looking at Fourier series expansion, something I know next to nothing about, but I do know that it is for like sines, cosines, waves, breaking down waves into their sines and their cosines, but we're going to be doing that anyway on x cubed, which is neither periodic nor symmetrical, but at least it is continuous. So let's do that, and we're doing it from negative pi to pi. That's our interval, so L is just pi. This is very relevant for Fourier series, which I've written out here. So we have a sub naught over 2 plus the infinite sum going from n, as n goes from 1 to infinity, times, or of a sub n times cosine of n pi x over L plus b sub n times sine of n pi x over L. So let's evaluate a sub naught over 2. What is a sub naught over 2? Well, it is 1 over L. So a sub naught over 2 is equal to 1 over L times the definite integral of negative L to L, or running from negative L to L of f of x dx. But, like I said earlier, L is pi, so I'm going to be plugging in pi here. I guess it doesn't really matter. You'll see why. Negative pi to pi of x cubed dx. Now this was the only integral I was actually able to integrate. The rest I used Wolfram alpha for, coming in clutch. I am too dumb to integrate the rest of them, so just the most basic integral possible using reverse power rule. Oh wow. So obviously we can integrate this really easily. X to the fourth over 4. Evaluate this from negative pi to pi. Now, negative pi to the fourth is just pi to the fourth. Pi to the fourth is obviously pi to the fourth, so we would have pi to the fourth over 4 minus pi to the fourth also over 4. Surprise, surprise, we get 0. Doesn't matter, we have this 1 over pi out front. This whole thing equals 0. So we have a sub naught over 2 equaling 0, very convenient. One term down, like 2 more to go. Next one is okay. So next up, we're evaluating a sub naught. Not a sub naught, a sub n. A sub n, much like a sub naught, is 1 over 2L, but in this case, it is just, sorry, not 2L. Oh, that's what I messed up on. Well, I did say it didn't matter, but, let's close the circle. A sub naught. It should be 2L, so it should be 2 pi. Should be 2 pi. Doesn't really matter because it's still evaluated as 0, but the point is I did mess up on that. My bad. Okay, now we have a sub n again. This time it's actually 1 over L, so we'll just replace that with pi. We'll multiply this by the integral, definite integral, running from negative pi to pi, I'm going to say that a lot, of f of x times cosine of n pi x over L, but f of x is just x cubed, and cosine of n pi x over L, we said L was pi, so cosine of n pi x over L cancels out the pi's, we just get cosine of nx, so we have cosine of nx dx, because we are integrating with respect to x. Now, Wolfram alpha also came in clutch here. This whole thing also evaluates to 0. So this whole term, since it's multiplying, just bam, 0. Very nice. Let me just write it down. Equals 0. Second time filming this video. If I make any more mistakes, I do not care. I want to go to sleep. Okay, next we have b sub n. Last thing we actually have to evaluate. Much like a sub n, it is also 1 over pi times the definite integral running from negative pi to pi of still x cubed, but instead of cosine, you guessed it, we have sine. Sine of, once again, the L and the pi, since L is pi, cancel out, and we have sine of just nx. I'm going to redraw that x. That's a bad x. X integrated with respect to x. Now Wolfram alpha did all the computational magic here, because this is a quite the annoying integral to integrate. You need like integration by parts or something, and I just barely learned product rule, so not looking so good for me to evaluate this out on hand. But it's okay, Wolfram Alpha has my back. This is just equal to the very concise and easy to write out 6 times pi squared n squared minus 2. Yeah, minus 2 times sine of pi n, or n pi, minus, let me put this in parentheses, minus 2 pi n times pi squared n squared minus 6 times cosine of pi n all over pi n to the 4th, because we still have this 1 over pi out front, so that goes down here in the denominator. Now, this is absolutely awful, because that's what goes in our infinite sum. This is awful. It sucks. It's b sub n times all this. It's terrible. Just kidding. Sine of pi n. Let's think about, since we're essentially chucking this in the infinite sum, let me actually write that. So let me do some rewriting here. That's what this integral equals. I hope you got that down. If you're like taking notes or something, I hope you're not. But this is. Can I just copy and paste this? Yes, I could. I very well could. I'm just gonna write it out here. Yeah, here. So this is the infinite sum running from 1, as n goes from 1 to infinity of all this. This is just b sub n, and now we have a lonely little sine of n pi x over L. The L and the pi cancel out, so we just sine of nx. Yeah, we have all of this as our infinite sum. Now there is some something we can do here, some little cancellations we can do out. So we have, as I was saying, sine of pi n. Let's think of sine on the unit circle. Sine of pi is 0. N is an integer, so sine of pi n is just going to be always 0. Since these two are multiplying, bam, this is nothing. This is 0. Now we just have the negative 2 pi n times pi squared n squared minus 6 cosine of pi n over pi n to the 4th times sine of nx. But cosine of pi n, let's think of cosine on the unit circle. What is cosine of pi? It's negative 1. And like I said earlier, n is an integer. We're integrating, or summing this. So, cosine of pi n just kind of flips between negative 1 and 1. It oscillates. So this is going to be rewritten as negative 1 to the n. That is literally all the simplifications that I'm willing to be doing. That is going to be an awful crop. I'm not doing that. Okay. So now Wolfram Alpha once again came in clutch here, told me that this infinite sum is equal to, or rather this portion of the infinite sum not multiplied by sine of nx is 2.8637, about approximately equal to 2.8637, and then we have sine of nx out front. Now of course we're multiplying this, and sine of nx, as n goes to infinity, sine's gonna oscillate between negative 1 and 1. So I guess maybe you could rewrite this as negative 1 to the times x. Just negative 1 to the n. Well, okay. Truth be told, I forgot about the sign nx out front. When I originally wrote this down, I looked past on my notes. I'm like, oh, there's a sign. I don't know why there's a sign. I forgot that b sub n is not the whole thing. It's multiplying sine of n pi x over L. And even though the L and the pi cancel out, you still have sine of nx, and I don't really know what to do with that. So we just have the sine of nx out front multiplied by this. Now that is fine and dandy, but I am like quite possibly the lowest down here in terms of my summation rule knowledge. So maybe it's equal to this. You could argue that, I don't know, sine of nx, like I said, as n goes to infinity, the sign just kind of bobs between negative 1 and 1, and so you have negative 1, 1, so just that diverges, but the sum converges and has cosine in it. That's negative 1 to the n, so in conclusion, it's maybe equal to this. Truth be told, I don't even know what you would use this for. Fourier series is for waves in like signal processing. So unless you're trying to signal process x cubed, a non-periodic, non-symmetric function, maybe it's useful for you. So yeah, it's maybe equal to 2.8637 times sine of nx, or maybe maybe it diverges. I don't know. Ask like somebody on Math Stack Exchange or something. They probably know the answer. Yeah, bad video, but I thought this was at least relatively interesting. Yeah, thank you for watching.